Here we have a three-dimensional view of a moment. We've got the moment is about the 0 point, and it's created by a force at a position R, and the force vector here is in red. And we can see this a little bit better if we do a little bit of rotation here. So we can see maybe that the moment is perpendicular to both the R and the F vector. We can also look at the angle between the vectors, and just as we did in 2D, but now we can see the angle is kind of oriented in 3D depending upon where the vectors are located. And just as in 2D, we have a parallelogram, and that's created with the vectors as edges, R and F. And we'll see that the projection of this area in the x direction is the same as the x component of the moment, and likewise for the other directions. But what we're really interested in here is that even though this is a three-dimensional problem, we can look at the components and treat this as three-dimensional problems. So here we have the components of the vector. And we can see, in this case, our force is going in the negative x direction. And I'd like to at least initially look at this as a force going in the positive directions. So the r vector has rz, ry, and rx, and the force vector fx, fy, and fz. Now, if I look at this from the x direction, so I'll look down the x-axis, and I'll again move these component forces. So they touch the position vectors. And we see that just as in 2 dimensions, actually this is the same calculation we did in 2 dimensions. Fy and Fz. So it's the same equation, again, we used in 2 dimensions for the moment in x. And we can look at the moment in y also. But there's a difference. If we look at our equation, we see that this moment, let's change it so that both things appear to be positive, but the moment in y is actually negative. The reason for the appearance this way is that we have the y-axis going backwards instead of forwards. So this view is really a kind of a left-handed view, so to speak, because the vector is going the other way. So you got to watch the sign a little bit, but still it's the same type procedure. And we'll look down the z-axis and see our same equations for 2D. Back to the angle, just to show the angle still gives you the magnitude of the moment vector.